Hello guys, welcome to LeetCode Daily Decode. Today we will be solving maximum difference between node and ancestor. So let's quickly understand the question. We are given the root of a binary tree. Find the maximum value v for which there exist different nodes a and b, where v equals to absolute difference of a and b, where a is the ancestor of b. So let me explain this question with the help of this example. So what we have to find is basically if the maximum difference between two nodes where one node is the ancestor of the other node, and what nodes are ancestor are basically, like, let's say we are at 8, right? So all the all the LHS, like left side of binary tree and right side of binary tree, every node is a basically child of this 8, right? So for 13, 8 is the ancestor, 14 is ancestor, 10 is ancestor. But for 13, 3 is not the ancestor because that is in a different side of the tree. So all the nodes and the subsequent nodes on right and left. So let's come to the example of 3. So 3, 6, 4, 10, this is one family, and 3 and 1 is a different family. So 3 is ancestor of all these nodes 6, 4, 7, and 3 is also ancestor of 1. For 6, 4 and 7 are like the child nodes, and 4 has ancestor 6, 3, 8, right? So I hope you are understanding what an ancestor and child relation here signifies, right? And we just need to find the maximum difference. So for this example, you have seen uh, like 8 and 1. So difference between 8 and 1 is the maximum, and that is why the answer is 7. uh, so the problem is very straightforward, and it can be done using recursion very easily. Let's quickly come to the solution. I'll explain how we are doing it. So yeah, this is how our solution will look like. Let's quickly understand what we have done here. So first of all, we have defined a recursive function, right? We'll come back to it later. And we have defined a max diff list. Why I have defined list over here? Because we'll be passing this to our recursive function, and we want it to update after every call. So if we would have passed maybe a variable, like a static variable, Python does not allow to update it due to the implementation in Python. So I pass it as a list so that it can be mutable in other functional stack calls, like in recursive function. So that is why it is a list. We have passed it to the recursive function, and we have like returned, as we just need to return integer, we are just returning the first value of this list. So this list is what we will be storing our answer, maximum difference basically. Now let's come to the recursive function that we have written. So it takes four parameters. First one is our root, second is the minimum value, maximum value, and max difference. So what we are doing is, starting from root, we are maintaining two variables, that is the minimum till now and maximum till now, right? And wherever we are calling to the left subtree and the right subtree, we are updating that maximum minimum value according to that. So for example, if we are at 8 and we are calling the left subtree for the recursive function, we'll be sending the minimum value as 8 and maximum value as 8. Now when we are at 3, we'll again call the left subtree, but now our minimum value will be 3, but my maximum value will again be 8, because among 3 and 8, 8 is max, right? But when I am at 1, there is no other chances. I'll just see the difference and I'll return back to 3. Now my 3 will call the right subtree, right? Now when I am coming back at 3, I should update my minimum and maximum till now. So if we would have not updated minimum value, our minimum value would be 1 then, right? But that is not the case, because that is a different ancestor or different family that we are talking about, if we are going to the right hand side of the tree, our minimum and maximum value should always be from the ancestors, right? Not from different family. So if we are at 3 again, we will again have to update our minimum and maximum value till now for this particular family. So our minimum would be 3 and maximum would be 8, right? Again we'll go to the right, we'll see our minimum would be 3 again, because 6 is greater than 3, and maximum would be 8, 6 is lower than 3, 6 is lower than 8. And then again it will go to uh, left side, 6, so our minimum will be again 3 and maximum would be again 8, because 4 lies between these two. And we are also doing some computation over here, just the difference part we are calculating and making sure that the difference is always maximum. And then we return back at 6. Now again at 6, the minimum and maximum remains the same. We go back to 7, then again we come back to 6, we come back to 3, we come back to 8, we go to the right subtree. And then again, now when we are going at right subtree, so we are again updating our minimum and maximum. So our minimum till now is 8, and maximum till now is also 8, and then I am going again to the right hand side. That is what I have done over here. So first of all, we are calculating our answer, right? So if we are at a particular node, what we are doing is we are taking the maximum of 3 values. First is the value itself, the answer itself that we are storing till now. Second is the absolute difference between the minimum value till now and the current root value. And third is the absolute difference between the maximum value till now and root value, because it may happen like in the case if 3 and 1 the difference is 2, but the maximum and value and 1 the difference is 7, right? So it may happen that we have a difference, absolute difference greater for in the case of maximum value or the minimum value till now. And then we are saving the current minimum and maximum value, because the stack will keep on increasing, because we are calling left and left and left. So it will go in the depth of the tree till the leaves. So till that time we'll be like our current value of minimum and maximum would be lost. So for the next recursive call we won't be able to save it and like correctly send the correct value of correct minimum and maximum value for that particular family. So then we have saved it in a variable named temp1 and temp2, bad naming again, but just for the sake of solution I have written. So temp1 equals to minimum value of till now, and temp2 is equals to maximum value of till now. Then we are updating the minimum value from the current root value and the maximum value from current root value, and we are calling a recursive function to the left node, left of what we have, right? So then it will go on and again change the minimum maximum value and finally give me some result that I'm saving in the maximum difference. But when I am again coming back to our current function call, like after this recursive function is being correctly implemented, I'll again have to update my minimum and maximum value. That I'll do with the help of the saved variable that I had and the current root value, right? So again I'll compare both of them and I'll send it to the right tree, and that is how we are completing this recursive function. And this will give us the maximum difference at last, and we are returning it, uh, the first value of that maximum of that list. Let's quickly run it and see. LeetCode has also changed its layout, so it's very decent and very like easy to use. Also they have this tree visualizer, which is very helpful in the case if you are writing your own test cases for specific for trees and all. So it is very good. You just need to click over there and you can see the tree visualizer. So we see that it is accepted. Let's quickly submit it. Yeah, so it is working fine, and um, so I hope you guys were able to understand the just behind this problem. Um, so see you in the next video. Thank you for watching.